So the next thing, guys, is that we're going to kind of go back to that altitude and how we're going to be able to use the geometric mean. Oh, okay. So let's go and talk about the altitude and geometric mean. Let's go and find this altitude, and let's call that h. Now, let's say I wanted to be able to determine the value of h. To be able to do that, let's cut these side lengths up into x and to y. Now, based on how these side lengths are written up here, I can say that that's x and that's y, correct? And both of these lengths are h. Would everybody agree with me? This is not a number. This is a theorem for the geometric mean altitude theorem. Would everybody agree that I took my x and y, h, and I wrote that down here? Right? Now, if I was to create a proportion, I could say that x is to h as h is to y. Would everybody agree with me? Right? Proportions have to be in corresponding sides. So what I'd do is I'd say x is to h as h is to y. Notice how the means are the same. Cross multiply. H squared equals x times y. Square root. H equals the square root of x times y. So therefore, we can apply the geometric mean to determine the height or my altitude. So if I want to determine this altitude, all I need to do is find the geometric mean between my two bases that have been cut up by the altitude. OK, Guillermo? That's very, very important for you to understand. I can find these two values. I can find the height if I know these two values by applying the geometric mean. OK? That's very, very cool. And again,